story begins in ancient Greece in 400 BC. At that time, man firmly believed that all things were composed of four basic elements: earth, air, water, and fire. But Democritus, a philosopher of that era, thought that these elements could be divided into smaller parts. In fact, he even gave them their name, atomos, which means indivisible.
I crumbled this earth to soil, and in turn crumbled this soil to dust. Now, if I could reduce this dust into its smallest particles, these would be atoms. This beach appears to be a solid carpet, but on closer inspection, we see that it is made of millions of grains of sand. If we think of grains of sand as atoms and pack them together, they can be molded into any desired form. So it is in this way nature uses these tiny particles, these atoms, to build all things: the earth, water, air, and fire.
If air and fire consist of small particles, how can they rise? They would fall to the earth like a shower of pebbles.
The man who disagreed with Democritus was Aristotle, a famous Greek philosopher. His philosophy shaped the thinking of man for the next 2,000 years. And so the idea of the atom was lost.
En la naturaleza nada se crea y nada se destruye. Todo se transforma.
One of the first men to explore nature's tiny realm was John Dalton, an English chemist. This was early in the 19th century. It was he who revived the idea of the atom.
I believe Democritus was right. All things are made of atoms.
Lights go out and I can't be saved. Tides that I tried to swim against brought me down upon my knees. Oh, I beg and please.
Atoms for sulfur in a match. Atoms for carbon in every ordinary pencil. Atoms for mercury in a thermometer. A different kind of atom for each element. But most of nature's creations are mixtures. This glass is a mixture of different kinds of atoms. The wood here, another. This book is composed of more mixtures than I could name.
Tigers waiting to be tamed, singing
Today I discovered something very strange. I happened to leave a piece of uranium on a wrapped photographic plate in a dark drawer. When I developed the plate, I found that it was fogged. A
Apparently, the uranium had exposed it, even in the darkness and through the wrapping. This uranium, it seems to possess some mysterious activity and give off some type of radiation all by itself. C'est extraordinaire.
Becquerel had discovered radioactivity. Pierre and Marie Curie, two other French scientists, were greatly intrigued by this strange phenomenon. While seeking the source of the radiations from uranium, they discovered a new element, which gave off even stronger rays.
Look, our new element. How radiant it is. It even glows in the dark. We should call it radium.
Radium turned out to be a mysterious source of energy. This remarkable element would go on radiating like an endlessly flowing spring. This was against all laws of science, known at that time. How could this tiny mass contain so much energy? This mystery shook the very foundations of science. Radium constantly releases tiny bits of its energy through radiation, a little bit every second. And there is so much energy that this activity can go on for thousands of years. These rays were actually tiny fragments of atoms breaking apart. No longer could the atom be considered the smallest particle in nature. Evidently, the atom was not an indestructible little ball after all. But then, what was it? The first clue to this question came from Lord Ernest Rutherford of England. The year was 1911.
Today, I used the fast-flying fragments of radium as tools to probe into the atom. I placed a small sample of radium inside a solid lead block. The lead absorbed all the rays except those that were allowed to escape through a small opening in the block. One might say it was a sort of atomic gun. To make the ray bullets visible, I used a fluorescent screen. For a target, I chose a very thin leaf of gold. But to my surprise, the bullets from my atomic gun passed right through the gold leaf as though it wasn't there. It was like shooting at a ghost. This was truly amazing because the gold leaf was a solid wall, 2,000 atoms thick. So the atom can't be as solid as we always thought. Then, unexpectedly, one out of thousands of bullets ricocheted, striking something solid. I can only conclude, then, the atom is mostly empty space, like a cloud or shell. But occasionally I hit something solid. It must be very small, a tiny particle in the center. I shall call it the nucleus of the atom.
With Rutherford's discovery of the nucleus, scientists began to understand how nature builds her atoms. The shell of the atom appears solid, just as a fast-whirling fan seems solid. Actually, the shell is composed of a whirling swarm of tiny electrical particles called electrons. They circle around the nucleus like planets around the sun. So the atom is like a tiny solar system. But scientists are ever curious. They began to probe the atomic nucleus for its secrets. They found that it was composed of small particles electrically charged. They call them protons, which means primary particles. Later, to the great surprise of science, other strange particles were discovered in the nucleus. They had no electrical charge. They were neutral. And so they were called neutrons. At last, the mystery of the atom structure was solved. Nature always keeps an electrical balance in her atoms. So, if the nucleus has 2 protons, it will also have 2 circling electrons. This makes an atom of helium. There are also neutrons in the nucleus that add to its weight. And so, by simple addition, nature builds the atoms of all her elements. 6 protons and 6 electrons and some neutrons for carbon.